Hello everyone. Today we're going to be talking about surface area. Surface area just means all of the areas of the surface added together. So one of the things that is helpful in figuring out, one activity you can do that is helpful to figuring out surface area is drawing it out, drawing the shape out like it was flat. So think of a box. When you get a box ready for recycling, you open it up, flatten it out. That's what I'd like you to try to do now. So try to visualize this opened up and draw all of the pieces connected, all of the sides connected on this grid. And then come back to see if we match. All right, so this is how I would go about doing it. But as long as yours might look different than mine, I'm going to start with this side right here. So I have my 1, 2, 3, 4, 5, 6 for this part right here, and then I have to go up 4. 1, 2, 3, 4, 1, 2, 3, 4, and that's where the split would be. Then I'm going to do this face right here. And so I still have my 6 going this way, but now I only have to have a 1, 2, 3. And then that's where my split would be. And then the face that is opposite or crossed from this face we have to draw in. So now I have to go up 4 again, because there's this 4. That's where the split would be. And then I have to do the face opposite this one. So 1, 2, 3, 4, sorry, 3, because it is 6 by 3. So that gives me all the way around it. Now I just need the top and the bottom. Each top and both the top and the bottom is 3 by 4. So I'm going to just choose to come off of this 4 and go over 3. So that would be the top. And so now this is attached right here, and I'm just going to do the other one right here. Now yours may look very different from mine. If I look at what other people have done, theirs do look different than mine, and I'll draw another example in a moment, but I want you to see we have a 4 by 3, so this is a 12. We have a 3 by 6, and there's 2 of them. We have a 4 by 6, and there's 2 of them. And we have another 3 by 4. So drawing it this way, if we add up all of these numbers, we have a total area, so a total surface area of 108 centimeters squared. However, let me try to get rid of all of this. We could have drawn it a different way. So some of yours might have looked like this. And I'm going to pause it so it's not so long and then come back. Alright, some of you might have drawn it like this, where you were picturing this part and its opposite face, so the 4 by 6 as the top and the bottom. So there are different figures that you could have drawn as long as you have 2 that are 4 by 3, 2 that are 4 by 6, and 2 that are 3 by 6. Some of you are very, very visual, and you can picture these nets right in your head. I am not. So I rely on the arithmetic or the algebra way of figuring it out. So I want to talk about that as well. So first, a right triangular prism looks like this. So here the top and the bottom are triangles, and it's right because we have our right corners. So the faces are all rectangle. This is a right rectangular prism, because again, here are our bases that are rectangle. And here is a right pentagonal prism, because our bases, our top and our bottom, are pentagons. And all of the sides form right angles. So I want to talk about the lateral area. This is a really easy way to figure out surface area of right prisms. The sum of the rectangular sides, so all of these sides, the sum of those, and they're called lateral faces. Lateral faces. The sum of those are the lateral area. So the sum of all of these sides. So not worrying about the top and the bottom. So to help us understand an easy way to figure out the surface area, I am going to have you write an expression that represents the lateral area for each, and I'll show you what I mean. So for the right rectangular prism, if we add up all of these sides, this side right here that we can see that's facing us, remember, to find a rectangle, it's length times width. Well, this length is height, because they all have the same height. Height times this right here, which is C. So H times C. And then if we go back, and it's right here, on this one, that one is height times A, because here's my height, and here's my, length and width. And so this one, it's height and B, so H times B. And we have to add them all together. Okay, so we have our height, and then we have it multiplied by each of our lengths. Okay, so that was the right rectangular prism. I'm going to pause it and see if you can do the same thing for the right rectangular prism. Alright, I was writing kind of big, but each of the rectangular sides, we had a length of A and a width of H, or length, width, whatever. So that's my A and H, A times H, and then I had another one in the back, so another A times H. And then I had a B times H to make up the area of this one, and another B times H over here. So this would represent the lateral area. And then the right pentagonal prism, so here's my right prism, and it's pentagonal because of the bottom. We could do the same thing. It's H is going to be one of our dimensions, A is going to be another, and then we could go all the way around. We have an A, a B, a C, a D, and an E. So I'm going to write this off to the side here. So we have A times H to get this face right here. And then we would have to go to this face, which would be B times H, and then in the back C times H, and then over here D times H, and then finally E times H. So A times H plus B times H plus C times H plus D times H plus E times H. So I'm hoping you're seeing a pattern. So what value do they each have in common? So the value that each of the parts, each of the terms have in common is H, because the H is the height for all of them. So if we were doing base times height or length times width, that H is consistent. So now this is where our friend the distributive property comes in, because we're about to make this very, very simple. So rewrite each in a factored form. So if they have H in common, we can pull out that H. So remember, the dance has already happened, so we have to pull out this H. And what are we left with? I'm going to write it in alphabetical. A plus B plus C. For the right rectangular prism, we can pull out our H. And again, I'm going to have it in alphabetical, so A plus A, or we could have written 2A. plus B plus B. And for our right pentagonal, once I pull out my H, I'm left with A plus B plus C plus D plus E. Stay with me because this is about to be the easy part. So in the parentheses, this is where we had our A plus B plus C, or our 2A plus 2B, or A plus B plus C plus D plus E. In each case, what do these represent? So this is where your mind has to make a leap. Remember that, and I'll use this as an example down here. For the right pentagonal, this is like the A, the B, and the C. So if you go all the way around a figure, what term does that give us? Think about it. I'm hoping that your mind made the leap to the perimeter. Perimeter. So for each of these, that was the perimeter of the rectangular base. This was the perimeter of the, triangular base, rectangular base, and the base that looked like a hexagon. So how can we generalize that lateral area? And this only works for a right prism. So remember where our faces are rectangles. So how can we generalize it into a formula that we can use every time if we are talking about surface area or lateral area of a right prism? So, since our lateral area in every case, and I'm going to say this is L, and I guess I'm going to use a capital A instead. LA, our lateral area, in each case we had the perimeter, so the perimeter of the base, times the height of the prism. So in every case, instead of having to do all of that math, if you just add up the perimeter of the base and multiply it by the height, that gives you the lateral. And then all you have to do is find the area of your two bases. So here is the formula for surface area of right prisms. We are going to find our lateral area first, which is just adding up the perimeter, multiplying it by the height, and then we're going to find the area of the two bases and add it on. So I'm going to find my perimeter first. I have a side that is 7.5 and one that is 10, and way down here, because it wasn't easy to write on here, is my other, so 12.5. So if I add this all together, this is 1, and then the 7, the 10, and the 12. 12 plus 10 is 22, plus 7 is 29. So the total perimeter is 30 millimeters. That gives me the perimeter of the base, and now I'm going to multiply it by the height. So to find my lateral area, I take that perimeter, and make sure that you're using the variables that allow me to see what it is that you're figuring. So here we figured the perimeter. Now I'm figuring the lateral area, so I took the perimeter and I'm going to multiply it by the height. So 30 times 15 is 450, and that's millimeters squared because we're talking area. So that gives us all the way around. So if I'm finding the surface area, I have my 450 plus, now I need to find the area of the triangles. And when you're finding the area of the triangles, the triangle base, it's important that you can see what side you should use. And I can see it the best on the bottom. Right here is going to be my right angle. So we are not going to be using this. This is going to be the base, and this is going to be our height of the base. So not of the whole prism. Remember, of the whole prism, that was my height. So remember how to find the triangle. 1/2 times base times height. So 1/2 times 7.5 times 10. So take a moment to figure that out. I came up with 375. So let me know if that is not correct. I did 0.5 times 7.5 times 10. Oops, sorry, not 375. That wouldn't make sense. 37.5. I dropped my decimal. Okay, so I'm going to take that. This is the area of the base. This is the lateral area, and we have to add them together to continue to get our complete surface area. So when I add those together, I have my 0.5, 7, 8, 487.5 millimeters squared. So to review, to find the surface area, you add up all the perimeter of whatever shape is your base, perimeter times the height of the shape, and then find the area of the bases and add them together. Except as I'm talking, I forgot one important thing, and I hope you guys caught it. I only added, this only gives me the area of one of the bases. We have a top too. So I really need to add in another 37.5, or I could do this. So 450 plus 2 times 37.5 to get a new total of, and I'll write it up here, sorry this is so messy, 525 millimeters squared. So don't forget, don't make the mistake that I just made as I was making this video. There's two of them. The only way there would not be is if it tells you it doesn't have a top. So you have to keep in mind what shape it is. If it's a shape that has a top and a bottom, you're going to multiply that base area times 2. If it doesn't, then you're going to leave it and just have 1. Okay. So just to review some of the concepts that we've talked about, we have our right prism, and please highlight this. We have a right prism. A right prism is when there is a shape on the top and the bottom, and they form right angles. So the two bases are perpendicular to one another. Okay? And then this gives you cube, what the surface is, net, and then we talked about how the surface area is the lateral area plus 2 of your bases, where the surface area is the area of all of the sides together, and the lateral area is just the rectangular faces added together. Alright, start your assignment, and do not forget to ask for help when you need it. We out.